Okay, hello everyone. Welcome to the webinar. We're really excited to highlight some of the innovative uses of computer vision. And this specific webinar is focused on how computer vision can be used to optimize the vaccine distribution process. So the coronavirus pandemic has affected nearly every aspect of our lives, from the stock market tanking to rising, to some of our favorite businesses closing, and a lot of us not being able to see our loved ones for a very long time. And we as an organization wanted to address how our technology can provide some solutions to this problem and help expedite and optimize the process of vaccine distribution. So I'm Komal Devjani. I'm a developer advocate at alwaysAI, and today I'm joined by Liz Oz, who's the head of marketing at alwaysAI. She's going to be addressing some of the statistics relating to the coronavirus, as well as the vaccination numbers. And then we have a very special guest here today with us, Manu Dwivedi, who is a med student at AUC School of Medicine. Manu is going to be showing from her perspective what the process of vaccine distribution looks like as a volunteer, what it might be like as a patient to get their vaccine. And she'll be addressing some of the key roadblocks and problem areas where computer vision can potentially come and help. And then we have Lila Mullany, who is a developer advocate and software engineer at alwaysAI. She has built a few applications that address these problems from a computer vision perspective. What are the ways computer vision can help? What are some of the key questions computer vision can help answer? And ultimately, how it can improve this entire process. So with that said, I'm really excited to invite Liz Oz for the next piece. Liz?
Thanks, Komal. Good morning, everyone. I just want to say thank you for joining us today. I'm happy to be here to talk about how computer vision can be used to, in some really innovative ways, ways that can have a positive impact on and improve people's lives, specifically in regards to the COVID-19 pandemic. And the COVID-19 pandemic, wow, it has fundamentally changed our lives in practically every way imaginable. And it's really served to be one of the biggest threats on humanity in the 21st century. So I just want to take a moment to look at the state of COVID-19 in the US. COVID-19 was announced as a global pandemic by the World Health Organization in March of 2020. Cases peaked in January of 2021, and there was over 200,000 reported cases at that time. Now, cases have dropped since then due to the new vaccine rollout, which is fantastic. The deaths and hospitalizations are going down, which is also fantastic. And we don't only have one vaccine, but we have three, which is incredible. We were able to produce these vaccines in record time, which is an accomplishment in itself. But with that, we were presented with some extremely challenging logistics to sort out as a society. How do you go about vaccinating over 330 million people just in the US alone as quickly as possible? And how do you ensure that the people with the highest risks are getting vaccinated first? So we began thinking about ways that computer vision can help with some of these problems. Next slide, please. So let's take a look at where we're at. 189 million doses of the vaccine have been delivered. However, only 147 million doses have been administered. That's 16% of the population who are fully vaccinated, and almost 29% of adults have received the first dose. The CDC advises that 60 to 70% of people need to receive the vaccine in order to achieve herd immunity. So what can we do to expedite this process? How can computer vision potentially help? Before we answer that, let's take a closer look at the end-to-end process that one has to go through to get a vaccine so we can get a clearer picture. Next slide, please. Okay, so the process, first, to get a vaccine, you need to log online, get an appointment, get on a waiting list, and then you wait for your availability before you show up to the testing site. Once you arrive at the testing site, you have to wait your turn. So you're going to stand in potentially 3 lines, one line to get into the building, another line where you wait to receive your vaccination card, and then finally a third line where you stand in to actually receive your vaccination. Finally, after you get vaccinated, you have to be monitored for about 15 minutes to make sure you don't have any adverse reactions to the vaccine. So if this all goes well, it takes approximately 25 minutes, including that 15-minute wait time. And that doesn't include any travel time to get to and from the site. Now, computer vision is an excellent source for these kind of scenarios, because you can potentially measure wait times, count people in lines. You can do mass detection, measure social distancing. So, computer vision really has the potential to help these healthcare workers in all phases of this process. Next slide, please. And that's where we come in. alwaysAI is a leading low-code platform for computer vision development and deployment on IoT devices. We make it very easy for developers and enterprises to create these computer vision applications. And by design, we're very flexible and we're very modular. So our platform can really be used for just about any use case. And we're currently helping a variety of enterprises across multiple industries create these custom applications to drive real value for their top line growth. And we can do the same for you. Next slide. So let me walk you through our platform, which consists of 3 main parts. We have our model catalog, which now contains over 100 pre-trained models to incorporate into your computer vision applications across all CV categories, including object detection, classification, pose estimation, and semantic segmentation. You can iterate really quickly by swapping out models at any point in your workflow. You can also upload your own model or train a model for your specific use case. Additionally, we have about a dozen starter apps which you can leverage to accelerate your development process. And the second part of our platform is our Python library of APIs. This allows you to customize and optimize your application for your specific needs. And then finally, it's our deployment engine. This allows you to deploy your app very quickly and very easily to a wide variety of edge devices. All these components combined allow you to create computer vision applications in a matter of days, which would typically take months or weeks to achieve. Lila will be highlighting in her demo the 3 components of the platform with her application. And with that, I'll hand it back to Komal, who will introduce Manu, our panelist, to talk about her specific experiences.
Thank you, Liz. And thank you so much for covering stats as well as highlighting the value of the Always AI platform. And now I'd really like to introduce Manu Dwivedi, who is a very special guest here today. Manu is an MD candidate at AUC, and she's currently a California native rotating through obstetrics and gynecology at Danbury, Connecticut Hospital. She's in a really unique position to track how various states are approaching the COVID-19 mass vaccination process, and she's personally volunteering to help get this process in effect. So welcome, Manu. Can you maybe start by telling me a little bit about yourself, how you got involved with the vaccination distribution process, and what really drove you to support in that area?
Sure. Thank you guys for having me so much. I'm very excited to be here. So like you mentioned, I'm Manu Dwivedi, and I'm an MD candidate, a third-year student at AUC. I was rotating in Connecticut, where we were able to volunteer to give out vaccinations to both the healthcare workers and to the first round of patients who are 65 plus with comorbidities. Because of our unique location, which is very close to the New York border, I was also able to cross over and work at Putnam County for the same reason. Yeah.
Amazing.
And so, yeah.
So what was the inspiration for you that, hey, I want to get involved with this effort. I want to volunteer the very little spare time I have as an MD student to...
I think it's really important that we all do our part. And I think a big part for me is to help roll out this vaccine, because I'm able to, and not everyone, has the opportunity to be so hands-on.
Yeah, that's amazing. I just want to say thank you for the contribution. I know I really appreciate it because I'm excited for life to get back to normal.
Yeah.
So can you walk me through a patient's end-to-end process of getting vaccinated? So from a patient's vantage point, what might it be like to go to the clinic and get vaccinated?
Sure. So let's say that you're the patient, Komal, and you've been told that you're eligible for the vaccine. You will be given a link to, in Connecticut, the VAMS website, which is a direct CDC website, where you'll make your appointment, which is a 15-minute time slot, and you'll be asked a bunch of just general questions, paperwork, birth date, etc. Once you get to the hospital on the day of your appointment, you'll be screened by security to make sure you have no symptoms of COVID, including a temperature screen. And then you'll get in line to check in. So check-in consists of answering several of the same questions that you answered online already. And then you'll get your vaccination card to prove to everyone that you've been vaccinated at least once. And you'll go inside our auditorium in Danbury because it was so cold. And then you'll wait if all the vaccination seats are full. You'll wait for your turn. After that, you'll have to wait a mandatory 15 minutes. Once you've been vaccinated in the same auditorium, you're maintaining social distancing the entire time. And we just make sure you're doing okay after the vaccine, you're not feeling faint or lightheaded or anything like that. After that, you can make your second appointment right away on the website, and you're free to go.
Interesting. So what are the lines like? So I know you were supporting it at a time when the vaccines were available only to a specific group or a specific demographic. How long were the lines at that point?
The lines did get very long. Like I said, we are inside because of the weather restrictions in Connecticut in the winter. So the lines would get quite long because there's a limited amount of space in the auditorium. So if we can't maintain social distancing inside, it's going to be very hard for us to keep bringing people in. So there were older patients, and I would say when they got in line, if it was a good day, maybe they waited 10 or 15 minutes, but if it was a bad day, I've seen the lines go out the door, and that's a good 30, 40-minute wait, easy.
Oh, wow. So, okay, these lines are going out the door. How is it being monitored that these individuals are social distancing from one another?
We do our best as volunteers to make sure people are social distancing, but we can only, keep an eye out on so many people.
So it's kind of like a manual process. You go one by.
Yeah, it's very manual, and it's very like if you happen to catch someone, because we're a human, we see people and we're like, hi, how are you? Especially in small towns. So
Does it even matter? Does social distancing matter if you're about to get vaccinated? You've taken the proper precautions to ensure that no one has any symptoms. It does. Is it relevant at that
I
point?
I think, it's a CDC recommendation that we maintain social distancing, and our hospital followed the CDC guidelines to a T. I would say, why risk anything when you can minimize it by just standing 6 feet apart and continuing to wear your mask?
Yeah, totally. Okay, cool. And so tell me about any dependencies or roadblocks that you have observed for patients during this process. Like what might be causing a delay or a lag?
Right. I think there are several roadblocks to the vaccination process. I think the biggest one, honestly, is like the waiting times, because our population was like older and the lines are really long for them. It's hard for them to wait like for long periods. So I think that, and then making sure that afterwards, once they've been vaccinated, that 15-minute time slot, if we could just somehow keep an eye out on everyone and avoid that human error aspect.
Yeah, totally. Okay, so how many people are staffed for this vaccine distribution process?
At our clinic, we had anywhere from 10 to 20 people, depending on who had the time. Obviously, the nurses were allotted more time, and the students had to find time from their regular schedules. So anywhere from 10 to 20.
Okay, so there's 10 to 20 people staffed, and they're responsible for monitoring the lines, making sure the vaccine's been successfully administered, and also monitoring patients post-vaccination in the event that something.
Yeah, yeah.
Wow. Okay. All right. So maybe you can walk me through the procedure. So after they've been vaccinated, are they being monitored in a room, or are they being do they just give a call like, hey, something went wrong?
So they're in a big auditorium where the seats have been marked off. So there's like one seat every 6 feet, including forwards, backwards, diagonally. And we just kind of walk around the room, and if anyone's feeling sick or any issues that they're having, they'll raise their hand or they'll alert us, and we're obviously also keeping an eye out to see if we see any visual changes.
Yeah. So how do they alert you? Is it by like?
Just kind of raising their hand or giving us a shout.
Okay, great.
Yeah.
Okay, cool. How do you, so, I think in just like learning more about always AI and the computer vision process, how do you think computer vision can potentially help automate some of these tasks?
I think computer vision can be really helpful in making sure that we can like automate maybe the waiting line situation where people are maybe told, hey, there's free spots now, you can come in. You don't have to stand in a line,
Yeah.
right? You can wait in your car, you can make sure you're being safe. I also think it'd be great to automate the phone calls when we have waste vaccines at the end of the day, because once you've opened a vial and thawed it, you need to use it the same day. It doesn't last until the next day. So those kind of things I think computer vision would be really helpful for.
Yeah. So the waste vaccines, what is that process like? How is it determined that, because that's something that we're all reading, right? That
Yeah.
there's vaccines available, but a lot of them are being wasted, and that's like value, right? That's
Yeah,
how
I mean, every drop is
valuable.
gold.
Yeah.
um,
How do you monitor that?
so each vaccine vial has 10 doses. Once we open a vial, like I said, you have to use all 10 doses. Otherwise, they're considered waste. We don't want to waste a single one. So we have a wait list, and we just start making calls. Or if anyone is kind of, I don't know if you've heard of this, but people are like chasing the vaccine, younger folk, they're standing outside CVS or Rite Aid and waiting to hear them say, oh, we have waste, so they can like go get their vaccine.
Yeah.
So we have a wait list and we start making calls.
Okay. Interesting. Yeah. And beyond just the vaccine distribution process, do you think computer vision in the healthcare space would provide value ultimately?
I really do think so. I think there's a lot of processes in healthcare that can be automated that don't need to be monitored by nursing staff or by people who could do more by giving out more vaccines, right?
Yeah.
For example.
Yeah, they can take on more responsibilities that doesn't require like the simple monitoring of
We
some.
just speed up the process and have more people come in, more people be able to get vaccinated. Because I think so, yeah, I think there's definitely a future for computer vision in healthcare.
Amazing. Well, I just want to say thank you again for joining us, and for those of you watching this, please ask any questions you have for Manu. We'll ask them at the end as well. So again, thank you so much, Manu,
Thank you guys.
all the information. And hopefully everyone got a chance to see like the problem statement of this vaccination space and some of the areas that do have an opportunity for optimization. And to address this, we have Lila Mullany on, who's built a few applications to highlight what are the ways computer vision can actually address these key issues, answer some key questions, as well as prepared a demo for us to see these certain applications. So with that, I'd like to invite Lila on to address some of these things. Lila?
Yeah, thanks, Komal, and thanks, Manu, for describing the process. So that really sets us up for talking about how computer vision can help, specifically with this vaccine distribution problem. For all of you here, you're probably interested in computer vision. That's why you're joining the webinar. But in general, computer vision is the process of a computer being able to analyze an image and then infer and make inference about what that image contains, much like a human would. And so that allows us to answer some basic questions like, are there people in this image, or where are the people in this image? So whenever I develop an application, my kind of first pass is to think about the question that I'm trying to answer with that application, specifically the questions that can be answered with computer vision for a computer vision application. So as Manu described, some of the really like specific questions are, should I call my backup list? But in order to answer that type of question, we need to answer some other questions first. And those first questions are the ones that we can answer with computer vision. These are questions like how many vaccinations have occurred, how many vials have been opened, how many people are in my waiting room, is my waiting room empty? So these are all like the first questions that I set out to answer with the applications that we're developing. And then also some basic questions that Manu described, like, are people social distancing? Are people wearing masks? Is anyone not wearing a mask? You can get really creative with the types of questions you can answer with computer vision applications. Next slide, please. So for this particular problem, because there are these 3 phases of the vaccination center, we thought it would be most appropriate to tackle it one phase at a time, as Liz described. alwaysAI is built to be very modular, and also I think that extends to the applications. You know, you can build them in pieces and coordinate them together. So the first application is really centered around that first phase of waiting in line and waiting rooms. So Manu described, you know, there's maybe like an outside waiting room and an inside waiting room. For this application, there will be an inside waiting room, but you could easily build on that, make a couple waiting room applications and tailor the application logic in each one slightly differently. You know, you'll see in one application, they're waiting in chairs. And I think that's pretty standard, but maybe outside they're standing. So you would alter it slightly for that. The second application is the actual vaccination process. And this will be different in different vaccination centers. But really it all comes down to capturing an event in a specific environment. So for this environment, you'll see that a vaccine is considered given if 2 people are in a certain space for a prolonged period of time. with the assumption that one is a nurse and one is a patient, and there aren't a whole lot of interfering angles and whatnot. But again, for your application, this event might be captured differently, and then you can tailor it to your use case. The third application is that last process, that post-vaccination monitoring for those adverse reactions. And this is actually really simple to capture with some models that are publicly available in our model catalog, checking for people who are raising hands. So you'll see that one. And then there is actually a fourth application that's not a computer vision application, but it is an application that aggregates all that data and just presents it to you in just numbers and suggestions and graphs, so that you can make inferences about the whole vaccination center together without having to look at those individual applications. With that, let's go to the next slide, and I will share my screen and we'll show you a demo of the applications that we built. Can you guys see this okay, Kamal?
Yeah.
Okay, great. Okay, so you'll see on the right-hand side, that will be the dashboard, the aggregator for the other apps. And then on the left-hand side, there'll be the 3 separate applications. And you'll notice they're using the streamer, which is a really handy way to debug, but it's not necessary if you want to run these applications without a streamer. All the data is just being sent to the server. So the first application that's going to be spun up, and you'll see that it's being started with AI app start. That's how we start all of the applications in alwaysAI. There will be one application that started a little differently, and I'll get to that later. But this first one is the dashboard, and it's coming online. And then the first one is the waiting room. I did want to start them in series so that you could see how the application handles the logic of no vaccines having occurred yet, or no people in the post-vaccination waiting room. This is all done with stock data, as that is the way we can prototype without having a real world situation for privacy and HIPAA compliance. That's just something we couldn't handle with right now. So you'll see that all of this data is a close approximation of the real world application, which is a pretty standard way to go about building the first draft of an application. Okay, so the server is online and we have our waiting room up. So this application really handled just checking a space for how many people are in it and how many people are in these different regions. So this is the check-in staff, and then chair 1, chair 2, chair 3. You'll see that we have red boxes around all these people, and that's because they're less than 6 feet apart from at least one person. So it's not enough that this person is 6 feet away from that person, or probably this person, but he's too close to this person, and vice versa, all these people. You can see that they're all wearing masks. So if somebody is not wearing a mask, if the model can detect that, it will be a red box. And if the model can't tell if there's a mask or no mask, but we can tell that there's a person, then there will just be a red box and be a label saying, I'm not sure. No, we're not sure if there's a mask or no mask. So that's some background. We're just going to wait while these people are waiting to get checked in. This is where they get their vaccination card before they get vaccinated. So you can see here's the first, just current status, just like a quick glance. We can see that everyone's wearing a mask, and here are some distances between the people. Obviously, there are a couple people that are closer to 6 feet away, but other people are very close. So it's just a helpful way to get a quick view. This is more of historical data. You can filter for less than 6. Sorry, that was originally different distances, and you can see historical sort of aggregations. So now people are moving, and we can see that on the vaccination panel, we don't have any data. It's waiting for data. No people have been vaccinated, so it's not doing any of its logic yet. And we can see that the same thing will be for the patient monitoring. So now people have moved along through the waiting room, and we can see that chair 3 was empty now. And we can see that it has availability. So that's some helpful logic you can use to tell people, hey, there's room in the waiting room, come on in. We can see, there's some real-time dips. Here we can see the capacity of that chair 3 was full and now it's not. So at this point, we'll start the vaccination app. And it started the same way the other ones were with AI App Start. So this application, as I mentioned, it monitors a specific region for 2 people to be in that region for a prolonged period of time. And you can set that time to be whatever is reasonable. The stock video was pretty quick, so we did slow it down or create a pause so you can see more of a real life approximation just for the waiting room or just for the vaccination process. So Manu described originally, about 4 to 5 minutes for the actual vaccine. That might be slower in some places, that might be quicker in some places. So for the purposes of this demo, a vaccine is about 30 seconds or so. That was kind of to find the happy medium between showing you what a real situation would look like and also not making you sit around for 5 minutes waiting for a vaccine to occur. But the idea here is that it's constantly checking to check if those people have moved, if they're in that region for at least the amount of time it takes to become vaccinated, then it will log that as an event. And that uses just like basic tracking. So you can see here that it could tell that one vaccine was administered. And you can see that that means that at least one vial was opened. And because we know that there are 10 doses per vial, there are 9 doses left. And there are 19 appointments remaining because I told the program at the start that we have 20 appointments scheduled today. That can change. You could have it pull from a database or text boxes on program start if that's an easier way to do it. This was just from a configuration file. And then we can also see the vaccination rate here. So that took about 30 seconds. So there's about 2 vaccinations per minute. And since we said the average vaccination is about 4 to 5 minutes, we see that the vaccination rate is quicker. And maybe we want to tell people in the afternoon or who have appointments in the next hour, hey, if you're free, you might want to come a little early because we're moving along at a good clip. That's also dependent on your use case. Maybe you don't want that feature, you can take it out. So this is the last application. It's for the post-vaccination monitoring. And you can see it started with AI app deploy. That's because it's being deployed on a Jetson Nano in production mode. And I'll talk a little bit about that after the demo, but I just want to show you that is what the deployment process looks like for that type of app. You can see it's slightly different than the others. And so what this application is doing is it's just checking for people who raise their hand, which is a really simple use case for computer vision. You just use key point detection and some logic. There's a couple applications on our GitHub that do very similar things. And then this adds in some logic that checks for a certain period of time. Okay, yes, a hand definitely did get raised for, at least, 1 second or so. So it's not contributing to alert fatigue and overusing it. On the other hand, we do log anytime a real hand raise is occurred because you want to make sure that those people are helped. And if they're not being helped, then you want to make sure another alert has been sent. So this is just showing a feature of the server that you can filter for data and export different reports if you want certain different measures to be checked. That's not computer vision related. It's just a handy feature. And that really goes into the versatility of alwaysAI, just being able to import different Python libraries and use the community developed tools. So while the post-vaccination app has been running, other events, vaccination events have been occurring. So you can see that there's only 7 doses left. And I'll hover over this in a second, but you can see that that means that there have been 3 vaccinations given. There's 17 appointments remaining. The vaccination rate is still about 2 per minute. So we're a little ahead of schedule. There's some other logic you can put in there. Is the vaccination rate slower? Are there any appointments left in the day? If there's no appointments left in the day and we still have doses left, then you start calling that backup list and that automates that. You can easily send an email or a text message alert automatically. So you can see that last vaccination event was logged. So now we have 16 appointments remaining and 4 have been vaccinated. And yeah, that's the, the app would continue running, but that gives you an overview of each phase of the application. And so with that, now that we've seen the actual demo, we'll go into how alwaysAI actually helped with this application development. So Liz mentioned kind of our 3 main attractions here with the public model catalog, the Python API, and the deployment. So really, every aspect of alwaysAI was leveraged with this application. And you can see, so what it means to be an alwaysAI application in terms of development. We annotated data using the computer vision annotation tool, which has been built into our CLI. And then Todd Gleed, our product manager, trained a mass detection model. He added it to a project and shared that with me. So projects and teams collaboration, I could then see the models that were on that project, test them out, add them to my applications. I also used models from the public model catalog. MobileNet SSD was tried for the person detection and YOLO v3, and then Human Pose and Human Pose Nano for the key points. EdgeIQ, our Python API, of course, was used. That really enables you to add in the core computer vision services like object detection, key point detection, tracking, really easily and simply into your application. So in addition to that, I mentioned that that last application was deployed on a Nano. And so that encompasses a few different things. First, I prototyped it on my Mac, and then to deploy it to the Nano, I just changed a couple lines of code to change the model, the engine, and the accelerator to be Human Pose Nano, TensorRT, and NVIDIA, so that it was optimized for that Nano. And then AI App Deploy, using a production device, allows the application to run continuously on that device until the device is powered down. And when it comes back up, the device will be up. So that means that I could do all this stuff on my Mac. And if I wanted to change it to a Pi or a Nano or some other supported device, I could do that. And that's because of containerization. And then, of course, you see here the production deployment. I just described that. So you can go from prototyping to production pretty quickly. You don't have to change the engine and the accelerator. That was specifically for the Nano. Really, all it is making that production device and using the deploy command. I also wanted to mention that all of these applications use the streamer, which is really handy for debugging, but it's not necessary. And if you're worried about visual feedback, you can omit the streamer. Everything is just then textual data being sent to the server. If you're worried about faces or anything like that, we have functions built into EdgeIQ that allow you to blur things in a bounding box very quickly. You can remove portions of images with cutting them out. It's super easy, super simple. So it's a really versatile way to prototype an application like this. And a lot of the stuff I use is already on our GitHub in bits and pieces. So the building blocks are there, like Liz said, it's very modular. And you can plug and play, see how quickly you can get this up and running. And with that, I'll hand things back over to Komal. She'll tell you how you can get started and build your own computer vision application if you so desire.
Thank you, Lila. I think that was a really great demo, and it certainly highlights the creative ways in which you can leverage computer vision and address some of these key problems within our society and our world. And so if you want to build your own project, something similar to this, get started. Register for alwaysAI at alwaysai.co. So you can sign up, start using some of our starter apps and customizing them and play with the platform. And next, what you want to do is identify a project. What business problem are you trying to solve, and what are some of the ways in which computer vision can help? So we, of course, wanted to solve this issue of vaccine distribution and how we can best optimize that process. So maybe there's a project that you want to work on, maybe there's a business problem that you're trying to solve, and consider the ways in which computer vision might be able to help. And then reach out to us, let us know how we can help accelerate your project. You can ask us any questions on Discord. I've posted the link in the chat. And our team is always happy to help. We're very developer focused. We love to really dive deep and help you sort your problems. And finally, engage with our community. We have lots of content in form of blog, how-to guides, and tutorials. And you can even join our Discord community, where you might meet others who are working on similar projects, or others who could potentially guide you on yours. And the key thing you could do also is schedule a demo. So you can schedule a demo by going on the link as it's written below. And we'll be happy to show you how to get started with alwaysAI and what are some of the key things you can do with it. So with that, I'm going to transition over to the Q&A section and address some of these questions that I see coming through. The first one is, I believe this is for Lila. How balanced was your data for mask detection, and what metric did you use for this?
Metric, are we talking about maybe the user can type in some extra details? Are you talking about how well it performed, or pretty much Todd handled the training and I tested it out to see if it worked. The data from my recollection was fairly balanced, although there were originally, we did do some data set cleaning, and I know Todd augmented the data. That would be a really good question, I think, to follow up on Discord if you want to get into more how it's still a work in progress as well. You could see that there's a certain part in the application where if the person was in that first chair, it picked it up okay. But then as soon as they tilted their head a certain way, also the masks in this stock video were very neutral colored. And so I think that made it even harder to tell. But I think originally the data was pretty well balanced, although if people were wearing masks in an image, they were all wearing masks. And if people were not, they were not. So we wanted to get some more that were balanced and from farther away. That was originally an issue where people were closer, and so they took up a bigger portion of the image with their mask on. It's also really tricky because people have lots of different masks and different, some people just use bandanas, or some people have masks that make it look like they have just a face. That one I don't think we'll ever be able to get around. But yeah, follow up on Discord if you want some additional information on there. It is tricky. And like I said, once we deployed it in this application, we could see some of the weak points of it too, where there's certain angles that it just wasn't picking up on, that you'd have to go back out, collect data, and pick it up. But I think in this type of application, what you're looking for is a good consensus. And if there's an alert that something is not being followed, then a human can follow up and be like, okay, no, they're wearing a mask, it's all right. Or maybe, they take it down for a second. There's a lot of caveats in this type of application that you'd have to consider and maybe code in some extra logic for.
Okay. And then I believe with respect to metrics, there was referring to accuracy, sensitivity, precision, F1.
I gotcha. Yeah, we're gonna have to follow up on that because I don't know them off the top of my head. But you can see how it performs in the application. Okay, but not perfect.
Yeah.
So.
Okay, and then this next one, I'd like to defer to Manu. In the medical industry, how would privacy be handled when using computer vision? Would computer vision be adopted considering any privacy concerns? And this viewer would just like to know your views on that.
Sorry, I think that's a great question, because I know in the medical industry, we really worry about violating HIPAA and maintaining patient privacy. With computer vision, the video monitoring, if it doesn't have audio, is already a step in the right direction, because it removes patient identifier audibly. Also, I think if we could blur out faces, That's another thing just through computer vision that you can do. And then within the hospital system itself, how the data is managed, how it's stored, and who has access to it really, limits violations of HIPAA. So if the video after, we've used it for our metrics is encrypted and no one else has access to it, and then it's properly disposed of, then there should be no violation of HIPAA.
Yeah. And to that point, Lila, what are some of the ways in which edge-based computing of computer vision can address these concerns and ensure that the data doesn't go elsewhere or in
Yeah. Yeah, I mean, the video doesn't have to be recorded. If it's live stream, then, then it's not even being stored. You don't have to have the streamers. It doesn't have to be visual seen by anybody if it's just being processed by an edge device. I mean, for actual HIPAA compliance, you'd have to consult the HIPAA regulations and go through all of those steps. So this is not saying that this is an end-all be-all list, but you can, of course, easily blur things out. You can, of course, not even watch the video. You can have it just be streaming, have it being processed by the models, have that data aggregated that's coming out that just says 5 people in a room. It doesn't say who the 5 people are. It has no notion of anything like that. So I think there's lots of ways. It depends on what you're looking for and like what you want the application to do. But if you're just trying to give it a little bit of backup for what the logging events that the humans are seeing and what humans are interacting with, giving them some help, this could easily be a very lightweight, kind of brief, what's the word I'm looking for? Like ethereal sort of thing. Like it doesn't have to persist. It's just there to help you, have an alert if somebody raises their hand. No one has to see anybody's faces. Nobody has to know any kind of identifiers whatsoever. Yeah. But again, if you're actually building a real world application that requires HIPAA compliance, then of course you're going to go through all those rules and regulations and make sure your application is compliant.
Yeah. And then, Manu, would there be a way to inform these people that they're being monitored? And is there something they can do if they would not like to be monitored? What are your thoughts around that?
Usually during the vaccination process, we do hand out consent forms. This is another thing that can be added to the consent form, I think. Other than that, I really do think this is a more hospital-based question.
Great. Okay, so and then this one is also for Lila. Is the camera or model able to determine if people are properly distanced, even if camera's perspective is at a poor angle, to detect the actual distance versus the camera's perceived distance?
Right. So in this case, actually all the distancing, because I knew the location of the camera, would almost always have a full human in view and it had a good angle. It didn't use any depth sensing whatsoever. It just used basic, like a kind of average height for humans and other hard-coded measurements to then estimate distance, because it wasn't necessary that it's exact. It just needs to be a good approximation. Obviously, if the camera angle is different, that will completely change your application. You'll have to see what that camera angle is and how it affects the perception. Also, I'm sure using a camera that has depth sensing capabilities would also help. So it's really like what you need your application to do, what that angle is, and then you're just going to have to assess it. But yes, it would, I'm sure, change, and that it might not, this specific application might not be able to handle that scenario without some modifications or a different camera.
Okay, great. And this is the containerization. It's handled by Docker, yeah?
Yes, yeah. Everything, so alwaysAI uses Docker for its containerization.
Amazing. And then follow up on the earlier question, depth sensing is possible for this use case.
It's possible in the sense that you could use a camera that has depth sensing case. Yeah, so alwaysAI supports the real sense. We have cameras that do depth sensing, so check that out on our supported devices and cameras. Our Edge IQ API will have all the possible API interactions. Like if we've written additional functions to handle those cameras, you'll see that in our EdgeIQ API. So yeah, real sense for sure. This application would have to be tailored if that was the question. But yes, you can definitely use depth sensing cameras with alwaysAI.
Amazing, great. And would it be possible to combine 2 or 3 models to get a balanced performance?
I'm not sure. Balanced performance, you mean like it runs and there's no, device strain? You can definitely use multiple models in an application. And I think what you're trying to do in that application and the device you're running it on, you'll just have to gauge that. On my Mac, it's definitely possible. If I was trying to run 4 models on a Pi, maybe it would start to slow down significantly. And then camera frame rate, all that sort of stuff. If you have like specific questions on Discord, there's, Tyga, Eric, Steve, other Steve, they're all there to help with like, more specific use cases and what models you're trying to run, what device is it. So in that sense, we definitely have a lot of starter apps and whatnot on GitHub that use multiple models. You're just going to have to try them out and see how your performance behaves.
Amazing. And then, the health industry is really focused on privacy, and we've kind of addressed this quite a bit. What would you say is the best way to find data for a production environment for the health system to build an application like that?
I mean, it is really hard, and that's why we use stock data. That is freely available. Well, if you buy it, there are some free videos available out there that are free to use for commercial and non-commercial purposes. So you can look for those like Pexels, Pixabay, that sort of thing. But it's very hard to find a video that suits your use case. So I think sometimes people, and myself included, will try and find a video that fits. And in that process, they'll start to realize, oh, this is not what my app is supposed to be doing. So really, your video defines your app, live or recorded, whatever it is. That is, people are asking about camera angles and distances. It really depends on the input data. So I think the first thing you need is to get that business use case. So if you have that business use case, you should have the data. If you can't do that, then hunting around for videos that you either have to pay for or that are free, that might give you a best approximation that you can then prototype with for sure. And then once you have that prototype built, then maybe find somebody who's interested in that application and get the real data. And then you're going to have to iterate. But the good news is that iteration is really easy with our platform. So if you have to make a best guess with your data, then you can do that and then come back to it and try to get the real data. But if you don't have that real data, you're definitely going to have to make application changes because it's just so hard to build an application without that first piece because that really defines the whole app.
Yeah, totally. Okay, and then the final question is for Liz. What are the costs associated with leveraging alwaysAI as a tool for building computer vision projects?
Hi. So the cost for using the platform?
Yeah.
So we have a variety of different options available. We have a really robust freemium version, and then we have some tiered pricing for premium and enterprise that can range between $59 up to $179. So the best thing to do would be to reach out to us, and we can work with you to understand your specific use case and recommend a plan that would be suitable for your needs.
Amazing. Thank you so much. All right. So with that, I just want to say thank you so much, Lila, for an amazing demo. Thank you, Manu, for joining us as a guest and really walking us through that process of vaccine distribution. And thank you, Liz, for really setting this up and informing us of alwaysAI, as well as the state of COVID. I hope all of you enjoyed this presentation, and it will be available on YouTube for viewing later. So check out our channel at alwaysAI on YouTube. There's a lot of great demos, tutorials, hacky hour videos that go through detailed code demos, and definitely join our Discord community. The link should be in the chat. So with that said, I'm gonna sign off now. Thank you, everyone. Take care. Bye.